So hello everyone, in this video we'll be solving another LeetCode problem, and the problem name is find the minimum area to cover all the ones, and this is the part 1 of this problem. So let us read the problem statement first. So you are given a 2D binary array named as grid. Then find a rectangle with horizontal and vertical sides with the smallest area such that that particular rectangle covers all the ones in the grid. Now you need to return the minimum possible area of that particular rectangle. So what the question is saying that you need to cover all the ones in the grids that are present with some rectangle, and that rectangle should have the minimum area. So this is what the question is saying. So let us understand with the help of one simple example how we can solve this question. So let me just draw one random grid. So I'm just drawing it roughly, but yeah, you can just so let's say I have ones present in the grid like this. So this is the grid that I have drawn. Now I'm not writing the zeros, the spaces which are empty, you can just imagine that their zero is present. So I'm not writing the zeros. So let us say we are given this particular grid. Now for a moment just forget this minimum term from this question. What is the other most important thing? The other most important thing is that the rectangle should cover all the ones. The rectangle should cover all the ones. So let us understand how we will find a rectangle which will cover all the ones. Obviously we need to find the first one in the row as well as the last one in the row. Similarly we will do same for the column, the first one in the column and last one in the column. Then only we will be able to cover all the ones, right? If you don't understand, let us dry run or let us understand with this particular grid that I have drawn. So we will check rows first. So we will say okay, if there is any one present here or not. So we find that there is no one present, so we will move down here. So we will say, is there any one present? Yes, there is one present. So we can mark like this is the first row where we get the one. So let us find the what is the last row where we are getting one. So we check here, okay, there is also one present. Now this row might be the last row, but let us search further if we get one in some other row as well. So we move down here, so we got one here as well. So this might also be the last row. Then we go to the next row, we again got, we know we didn't get any one here, so we move forward. Okay, so we reach the end of the grid here. So we can say that okay, this is the last row we are getting one, and this is the first row where we are getting one. So this is the first row and this is the last row. So can't we say that this is the like width of the rectangle, right? Because to cover all the ones that are present in a particular width, we need to have the first one where it is occurring and the last one where it is occurring. So we can do that by matching the rows, right? So we will find the first row where we are getting one and the last row where we are getting one. By this way we will be getting the width. Now to get the length, we will do same with the help of the columns. So we will search here in the first column. Are we getting one here? Yes, we are getting one here. So we will say that okay, this is the first column where we are getting a 1. Then we will search on further which is the last column where we will getting 1. So this is the next column, we are getting 1. Okay, this might be the last one, last column, or this might not be the last column. So we'll keep on searching further until we reach the end of the grid. So we search here, no one present. We search here, okay, one row present, one present. So we search here, okay, again one present. We search here, 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 no one present. We search here, we reach the end of the grid. So we realize that this is the first column where we are getting one, and this is the last column where we are getting one. So can't we say that this will be the length of the rectangle? Yes, obviously, to get the length of the rectangle such that it cover all the ones, we need to find the first column where we find one and the last column where we need to find one. So this will be the length of the rectangle. Now what will be the area? The area will be simply length cross width. Now how will we find the minimum area rectangle? Now if you just analyze this problem closely, this area that we will get, this will be the minimum only. Why minimum? Because we are just taking the boundary ones. Now if we are taking the boundary ones, let us say for example, let me draw some other grid and we will understand how this area will be the minimum one. So let me draw another grid. In what case we can say that our particular area of rectangle is not the minimum? We can say that, let's say this is the first row, this is the last row, this is the first column, and let's say this is the how ones are present. So in this case, what will be the minimum area of the rectangle? First column, last column, first row, last row. So this rectangle will be the minimum area rectangle. Why? Because we are just taking the boundary ones. Now let us think what rectangle will not be considered the minimum. Obviously if we take some any extra cells, let's say if we take a rectangle like this, if we take this rectangle, obviously this is not the minimum, still it is covering all the ones. But why it is not the minimum? Because we are taking some extra cells where no one is present. But if we are taking only the cells where ones are present at the boundary, so in that case that particular area of the rectangle will be the minimum area of the rectangle, right? So the area, how we are calculating, by finding the minimum row, maximum row, same for minimum column and maximum column. By that particular scenario only we'll be getting the minimum area of the rectangle, because we are just taking the boundary ones. We are not expanding our area of the rectangle beyond those boundary ones. And if we are not expanding our area of rectangle beyond that boundary ones, that particular area of rectangle will be the minimum one. So I hope you understand this intuition. If you still don't understand, you can just try it out by taking some examples by yourself. But this is how the solution of the this particular problem will work out. Just find the first row, last row, first column and last column. Just find the length, just find the width, and just multiply them. You will get the minimum area of the rectangle. So I hope you understand this explanation. I tried my best, but if you still don't understand, you can obviously try some example test case and try it out yourself. You will understand why this particular intuition works. So let us see the code now. The code is exactly similar to what I have just explained you. So let us move to the code now. So this is the code. So first I have declared the size of the grid n cross m. So I have taken variables n and m for the size of the grid. Then I am initializing my r min, that is the row minimum, r max, that is row maximum, c max, that is column maximum, and c min, that is column minimum. Now we are finding the rows and columns for the minimum row, maximum row, minimum column and the maximum column where we are getting the ones. So we are just iterating at each and every cell of the grid, and wherever we are getting one, we are just updating these variables by that particular I comma j, or rather I or j, not I comma j, I or j. So we'll be getting the r minimum, r max, c minimum, c max. Now how we calculated the area? Just we have the side 1 and side 2. So side 1 will be what, you can also take it length or width or whatever. These are just the name of the variables. So how will we find the sides? Sides will be obviously easy to calculate. The row max that we are getting, we'll just subtract row min by that and plus 1. This is how plus 1. This is how we'll be getting the side 1. And similarly col max that we are taking, or c max that we are taking, minus c min plus 1. This will be the second side. Now to get the area, just multiply side 1 and side 2. That is what we are doing. R max minus R min plus 1, C max minus C min plus 1, and just multiplying both the sides, and we'll be getting the area. So I hope you understand this problem. This was easy kind of problem. It was marked as medium, but yeah, this was the intuition behind the problem, and this is how the code works. So I hope you understand this solution. Thank you for watching.